subject. Could we change the subject now? I was knocking on your ears, don't be you were always out, looking towards the future.
Okay, so for this one, we are supposed to write the Taylor series expansion for f of x equals sine x at c equals pi over 2 now. So this is our center. This is not Maclaurin because it's not 0. So this is our center. Alright, so what we have to do here is we're writing the Taylor series expansion, so we have to basically keep writing out the terms themselves. That's what I would suggest. And then we'll try to find a pattern in it. So let's find f prime of x. Well, yeah, okay. So we'll find f prime of x equals cosine x, and f double prime of x. So I'm going to find up to the fourth derivative, and then I'm going to evaluate them at this c value of pi over 2. So then we have negative sine x, and then f to the third, the third derivative is negative cosine x, and we're back to the fourth, which brings us back to sine x, which was our original. So now when I plug in pi over 2, let's do the original one. So that would be sine pi over 2, sine pi over 2. That's going to equal 1. And then f prime of pi over 2 equals 0. F double prime pi over 2 equals negative 1. F triple prime of pi over 2 equals 0. And f, the fourth derivative of f, evaluated at pi over 2 equals 1. Okay, so see here how the odd derivatives, the first and the third, they're both 0, right? And the even ones are actually the ones that are retained here. So I'll continue on to the next slide. And what we have is actually our Taylor series expansion is going to be 1 times x minus c to the 0. And this is like over 0 factorial, right? And then we have plus a 0 over 1 factorial times x minus pi over 2 to the 1 power plus, and then, so these are our, this is our f of x, f of pi over 2, and then we have our f prime of pi over 2, which was 0, right? And then our f double prime at pi over 2 was negative 1, okay, over 2 factorial, x minus, we'll just fill in the rest according to the formula, basically. And then we have our 0, this is f, the triple prime, remember the odd ones went to 0, times pi over 2 to the third, and then I'll put the last one right here, plus, and f, the fourth derivative of f was 1, so I'll put that here, and then x minus pi over 2 to the fourth. Okay, so this is how much I did. I mean, you can go further if you want, but we kind of get the gist of it. These terms go to 0, right, because of the 0 on top. So what we actually get is t of x equals, and then here we have a 1, right, because this term here is anything to the 0 power is 1. So we have a 1, and then we have a minus 1 over 2 factorial, and then times x minus pi over 2 squared. And then we have a plus 1 over 4 factorial, x minus pi over 2 to the fourth. Okay, so what we can do now is basically we have enough terms to characterize the series. So we're going to write it as a sum, as an infinite sum, from n equals 0 to infinity. And we see a switch from positive to negative to positive. So that means we do have to have a factor of negative 1. And we can check to make sure that when n equals 0, this becomes a positive 1, which is our first term. So that's good. We can leave it like that. And then we also have a over something factorial, right? And we see that they're all even. So when you have even numbers, you want to write 2 times n, okay? That makes anything even, okay? And then we also have our x minus c part, which is now pi over 2. And then we have only even powers. So again, that'll just be 2n. Alright? So that's it. This is our Taylor series for the given function.